What you see on your screen at this time is the Safe Harbor Statement, which serves as a reminder that this advisor webcast is intended for information purposes only. Any features or functionality described for Oracle products remains at the sole discretion of Oracle. Now, let's get started with our presentation. Andy, if you're ready, I'll turn the webcast over to you, and you can begin now.
Thank you. I'm ready. Hi, hello everybody. My name is Siebel. I'm Senior Principal Technical Support Engineer at Siebel for about now 12 years. And today we will talk about Siebel Product Modeling Best Practices Part 2. This is how you optimize the product modeling for the Siebel evaluator. That's the agenda for today. First of all, we will talk about some attribute design tips and about rule and cardinality design tips. And we will have a few slides about UI best practices and scripting best practices. And at the end, we have some miscellaneous points I would like to add. And then a short summary and a QA session. Okay, let's start with attribute design tips. The first one is a quite easy one. It's about attributes versus resources. Resources are a kind of global variables available from the iLog engine. And the engine, in order to use those resources, the engine must use extra constraints to the model to help enforce the user-defined constraints. And this means additional possible performance problems. Therefore, we usually recommend to replace resources by attributes, which usually can cover all the functionality resources have. Furthermore, for attributes you have a API with get attribute and set attribute, while for resources you don't have any API or possibility to get them by scripting. The next tip about attributes is about the definition. Whenever possible, we recommend to set up attributes as integers or as number values, which allows you to use specific constraint rules like comparisons greater, less, greater, equal, or less equal. This is not available for data type text. If you don't want to see those attribute values, then you can still use the attribute value display names and override the numeric LOVs, and can still use integer or numeric values. It will simply give you more flexibility and possibly reduce the number of constraints you have to define. And the last tip about attributes are some enhancements we introduced with ACR 502. ACR 502 is available with the 8.0.8.1 code line. And I wanted to take the opportunity to give a short overview of some attribute enhancements we introduced. The first one is creating a Siebel configurator engine read-only attribute. This means that you can set up attributes which can only be changed by the user. They cannot be changed by the iLog engine, so they are read-only for the iLog engine. And this enables users to define attributes that can serve as an input to computer-valid solution, but they cannot be changed by the iLog engine, which sometimes generates some surprises by users in the past, and therefore we decided to offer such a possibility. The next one is also something which was difficult to set up in the past. You can set up session-specific computed attributes. You can name them as a kind of temporary variables. They are not synchronized to the database, but they still have the same functionality like any other attribute. So quite useful in some situations where you only need a temporary attribute to keep some values and don't want to create an additional attribute on the product definition. And the last one was the result of reducing the necessity of scripting. Now we have the possibility to bind an attribute value to a line item integration component field. So the value can come from a quote, from an order, or from an asset item field. And the value of this business component field is on start, it's loaded into the attribute. and when you exit the evaluator session, then the value of the attribute is stored back to the line item integration component field into the resulting forward order or asset item field. This was only possible before we had this enhancement. This was only possible by adding some scripting. Now you can do this very easily by setting up a simple property in the product model. Okay, then let's go to the next big block, which is about rules and cardinalities design tips. The first one is a quite basic information, smart use of constraints, which means that there are two possibilities when you set up constraints. You can still let the customer choose everything, or you can use the constraints in a way that the user only has to make a few small changes and everything else is automated by constraints. So constraints can be used to make a session faster, easier for the user, and quicker to go through the configuration at all, and also enables him not to make too many errors. Furthermore, if you can add additional constraints like helper constraints, you can help the iLog engine to reduce the search space and improve the performance. This is especially sometimes important if you have something like mathematical strings like x plus y is equal to z. If you are possible to set up a kind of helper constraint which tells the engine that in specific situation x has a specific value and possibly then reduces the possible values for y, this will definitely reduce the search space for the iLog engine and helps to go quicker through the whole session. So always think about whether you want to use constraints only as giving the customer violations or limitations, or whether you want to create the constraint as a kind of guidance through the whole session. Next one is about avoiding hard-coded product exclusions. A constraint in the first line here, product A excludes product B, is named as hard-coded because we have two fixed operands. We have product A and product B. And if you want to change the constraint, you have to go into the product model, lock it, you have to change it, you have to release it and refresh the cache. So whenever possible, try to generalize the exclusion and possibly try it by using an attribute exclusion. Unfortunately, the current situation with attribute exclusions is that it sometimes generates a weird Siebel iLog engine behavior. So from my point of view, I would usually recommend to use product compatibility rules. Product compatibility rules have the advantage that you can also control the scope. So the compatibility can be used for multiple products without changing anything in the product model. It can be used for the whole code or for all assets you already have on the system. And it's easier to maintain because you remove it from the product definition itself. Let's see a screenshot from a typical example how you can replace a hard-coded exclusion by a compatibility rule. On the left side you will see this red X, which marks the place where we have this exclusion. And on the right side you have a compatibility rule, which is defined in a compatibility matrix and allows you to keep the whole stuff away from the product model and make it easier and simpler to maintain. Next one is about constraints on products and promotions. With 7.8 we introduced the concept of promotion, or even with 7.7, and what you can do is you can add additional constraints and promotions, additionally to what is on the product. So this looks quite excellent functionality, but has some problematic side effects. One is that you can create conflicts which cannot be simply resolved. For instance, the promotion rule excludes the attribute value which has been defined as default value at product or class level. Or a promotion rule excludes a product from a relationship which has been defined as a default at customized product level or class level. So, and you also have to think about what happens if you change the product definition later. And you also have to check all the promotions where this product is used and check whether you still have no problems with the additional constraints. So whenever possible, we would recommend that you have the constraints only on the product or only on the promotion side, or if this is not possible, then try to keep the product model simple and add the constraints to the promotion. The next one is based on the defaults we are using when we create a new relationship. Specify a realistic maximum cardinality. If you define a new relationship, then you will have three fields for cardinality: min, default, and max cardinality. And the max cardinality is set to 999 per default. This is actually not a good value and should be changed to something which is realistic to your scenario and can have a very significant performance improvement, because the higher the numbers, the greater the search tree for the iLog engine. It has to go through many possible values in order to find a solution. And how you can do this? Let's see a screenshot. On top you can see a typical default cardinality rule, and below you can see a screenshot of something which is modified to the customer's needs. In this case, we only have the possibility of adding 3 charger products as maximum. This one is based on naming conventions, name standard conventions you should create. We already mentioned this in the first part. Create a guideline for creating products. And one of these guidelines could be that you should always enter a name, description, and explanation field on the rules. Don't use the quick save mode and save a rule only with the necessary fields. Here again a screenshot where you can see on top we have a quick save rule. We only have the constraint field filled up, which is the rule definition, but we don't have any explanation or name. And below we have something which is based on best practices. We have a reasonable name which allows the administrator to recognize what is the rule about, and we have a reasonable explanation. This is especially important if you run into a conflict with this rule and you want to see additional information. Then the explanation part is used and will be shown to the user. This usually makes much more sense, a reasonable explanation, than showing the constraint, which has a specific syntax and usually doesn't tell the customer a lot of really important stuff. Okay, next one. It's about avoid rules from parent against child or grandchild items. You can also generalize this. You can say avoid rules which go through different levels, whether they are from child to grandchild or whether from rule to child. Basically, they are computationally very expensive, and you should always think about alternatives before you really need to set up such a rule. This can have a significant performance improvement. And the next one is about writing compound rules. Compound rules makes it simply easier to understand rules. It makes it easier for the administrator. And there's an example. You can set up 3 rules which has the name A excludes B, A excludes C, A excludes D. But you can also write this one rule which has the same meaning but is much smaller and clearer to read it and understandable. We have also the possibility of using tuples. I don't know whether you know that, but the basic language for the iLog engine is RAL, that's the rule assembly language described in the Siebel bookshelf. And this language has a syntax element which is named tuples. And what it does is you can write, if you have a lot of very rules which are very identical besides the operands, you can simply write up the rule by using variables and then add the operands you need at the end of this rule via brackets and pairs. This allows you to have only one rule, which might be a replacement for 5, 6, or 10 identical rules where only the operands are different. If you go into the Siebel bookshelf under the product administration guide, you will see some examples how to use this. The advantage is usually it improves the maintainability and sometimes can also improve the performance. Avoid constraints for upsell messages. That's actually something which came from the days before 7.8. In 7.8 we created a new framework, UMF, Unified Messaging Framework, and we added the product recommendation functionality. But before, a lot of users tried to write upsell messages by additional constraint rules on the product model. And the problem is that you have simply additional constraints on the product. It's specific for this one product, and it simply makes the product more complex. So therefore, we recommend use a new product recommendation function and the UMF framework to generate your messages, and remove those upsell messages from the product definition. As a trade-off, the upsell messages from the UMF framework, they will be shown in a specific applet, named, you can say that's a messages applet. And if you want to use messages during the e-configurator session, then you have to create a view, or you have to use a view where this messages applet is available. Next one is a very easy one, cardinality instead of quantity rules. You should always replace all your quantity rules by cardinality definitions. It's much easier, it's better for performance, and in the best case, you can, let's say you have only 1 or 2 rules with quantities, then you can simply remove all the rules and replace them by cardinality rules, which means that you can avoid using the dialog engine at all. So it can have a major performance improvement. That's a screenshot of how you can replace quantity rules by cardinality. On top we have a typical rule which describes that the quantity of a charger product can only be 1. And below we have a replacement where you can simply define the max, the min, and the default quantity to 1. You will get the same, exactly the same behavior than with the rule. Yeah, one point which is often forgotten, effective messaging. As everybody will know, we have display message templates, rules which can be used in order to display messages. And never forget that you can those type of messages to guide the user through the configuration, which might be very useful for a user, could help him to faster go through the configuration and improve the usability. And last but not least, whenever possible, write your product model in a way that you don't need any constraints. The constraint engine, the dialog engine, is a quite resource-hungry C++ part. It will also need it will consume a lot of performance. And whenever you can avoid it by using some alternatives, then do it. Don't write only one constraint if you can replace it by something else. This has a major performance improvement. Okay, that was about rules and cardinalities. Now let's go to the UI and about some best practices, how to design your user interface. First rule is avoid creating product-specific Siebel work templates, SWT. What does it mean? Whenever possible, you should group all your products in, you should group your products. So these products should have a very similar or identical user interface. And this allows you to define the user interface only once and use it multiple times for all these products within this group. It will reduce the design time, it will help to improve the maintainability, the user doesn't need to be retrained, and you have a reduced time to market. How can you do this? Usually you would set up one product with a definition for, like on the screenshot. We have a base theme definition, we have a product theme definition, and a UI control definition. This all could be set up in a dummy product, and if you want to create a new product from this group, you take this dummy product and make a copy of it, and then you already have kind of a standard user interface, which then only needs to be changed for the specifics of this product. For instance, you have to add some additional UI controls or change some attributes or whatever. But all in all, the basic UI layout looks always the same. You have on top, you have the tabs, and you have automatic repricing or whatever, and the customer is used to that and can work with this at once. Next point is about the standard JavaScript files. In the eConfigurator, we use a lot of JavaScript files in combination with the Siebel web templates to create the interactivity behavior. And the recommendation is never change those vanilla JavaScript files. There are around about three of them: ecfg-comment.js, ecfg-ui.js, and the third one, I don't know. But anyway, never change them. Simply create your own custom JavaScript files and enter them to the product model by adding an include statement on one of the Siebel web templates. The advantage is that you have a smoother upgrade. The problem is if you install a patch or make an upgrade, then Siebel does not recognize that you have made changes to the JavaScript files. So they will simply be replaced by the standard ones if they are part of this installation. And you have to do your work again, rework all the changes and add it again to these files. And the other point is also important. If you leave them as they are, you don't have any adverse effects elsewhere in the application. These files could also be shared with other modules, and if you make changes, and this can also influence places, you simply do not recognize at this moment. So don't change those standard JavaScript files. This one is also something from our experience with customers. Some customers tend to create one single large page with all the controls in it. They have a huge product definition with maybe thousands of objects, and they move everything what they can do. They move on one page with scroll bars and whatever, with complex controls, and then are very surprised if the loading of UI is very slow. Basically, performance of loading a web page is proportional to the number of elements. So therefore, keep the number of elements low. Try to create a page where you can see everything on one page, where no scroll bars are necessary, and keep it easy. So as an example, here you can see there are only as many elements as necessary, and there are no scroll bars. Everything can be seen on one shot, and everything else is hidden under additional tabs. Next point is about UI customization itself. You should keep it simply at a minimum. We provide a lot of flexibility to build a product user interface layout. We have a lot of controls to offer. You can add your own web programming and so on. But the recommendation is you should only build what is required and not what is desired. This is also some additional hints here on the two tech notes you can access from my work support. Again, the advantages here are you have reduced product design times, you you improve the performance, and you have a reduced time to market, especially if you create new products. And as a basic recommendation, keep your user interface simple. Aim for minimal number of items on each page. Aim for minimal items under control, which means don't have very long pick lists. Keep the number of items within the pick list maybe between 1 and 20. Avoid horizontal vertical scrolling, and if possible, avoid drill downs at all. And you know that if you have a child item which is customizable itself as well, it will be shown as a drill down. You can drill down into this child item and can make additional changes. What can you do to avoid this? You can use attribute inline display. Attribute inline display is a possibility in the Siebel web template which allows you to add the attributes of a child item side by side with the child item itself. So you can, if this is enough for the user, then this is an easy possibility to avoid the drill down. You can customize the child item here on this page as well. You don't need to drill down, come back, and so on. Makes it very easy. The trade-off is that it can reduce the performance if not used wisely. For instance, if the child item has many attributes, it probably does not make sense to show them side by side. Or if the attributes are pre-defaulted and user hardly needs to change them, then it also doesn't make sense to show them. And then you should not use this feature. Okay, that was about user interface best practices. Now let's come to scripting best practices. That's actually one page which simply summarizes the do's and don'ts. Basically, whenever possible, avoid scripting as much as possible. Scripting has almost always a negative impact on performance, on scalability, and maintainability. It simply makes the product model more complex to understand and to foresee the behavior, especially when you have scripting and rules combined and both influence the product model when the user customizes the product. So the do's say, first of all, you should follow the Siebel's strict scripting guidelines, keep the volume of scripting at a minimum, and use scripting only when you cannot replace it by rules, for instance, for complex mathematical operations, or if you want to communicate with external programs. Basically, there are no limits for scripting. You can still use all the Siebel APIs which are available outside of the eConfigurator as well. But you should simply be careful what you do. Especially don't try to replace rules with scripts, and usually don't refer relationships or items of relationships with scripts. Link items can also be an issue. And what you should never forget is scripting is based on the dialog engine event handling. The scripts are fired on specific events. For instance, if you change an attribute or change the quantity of a child item. If you don't go through the eConfigurator API, then scripting is not fired either. This is important to know, for instance, if you work with bulk requests. Bulk request is a standard functionality which does not use the eConfigurator API in order to manipulate the product. It will simply do it by simple business components API calls. This is much faster, and then at the end it will simply call batch validate to check the product definition whether everything is okay. But what happens is, because it doesn't go through the eConfigurator API, no script events are fired and no scripts are executed. So please be aware of that. And if you do it by yourself, if you go through the business component logic to make changes to a line item with a customer product, be aware that your scripts are not fired. So, miscellaneous, the last one for today. First one is very important from my point of view. Consider pricing requirements as early as possible. It has a very large single influence on the product design. Typical question for you is, for instance, you can design a product with child items, or you can do the same with attributes. What do you want to do? What is a better approach? If you think about pricing, how do you want to do the pricing? then maybe this is also already answered. For instance, if you say, okay, I want to use attribute-based pricing, then it's actually clear that you can't do the design with child items, you will do it by attributes. So always think about, as early as possible, about how you want to do your pricing, what makes sense, and then have your product design based on this as well. It will simply reduce the possibility for delayed product model changes or for scope creep and other surprises. Next point is about the joint workspace. A lot of people only think that the workspace is only be possible to import and export products or customizable objects or version objects, but this is not the case. The workspace project can also be used as a single point of entry to administer a set of product information together before they are released. So you can simply add all your related objects into one workspace object. You can set a future date, you can make some testing with this future date and can see the behavior of such objects even if they are not released with a future date on quotes and orders or agreements. So it can be used as a single entry point for the product administration, and it's actually easier to migrate between environments with this approach. So I would strongly recommend always use a joint workspace to administer your products. And the last one is about linked items. Be careful with linked items. Linked items can have a negative impact on the performance. This is especially correct when the needs execution set is true, because then you have a business component-based definition, and the performance can be strongly dependent on the search and sort specification you set up and the business component field you query. So therefore, we also have some other possibilities to define linked items. You can, for instance, use the context service, which will be explained on the next slide a bit more. And another point, which is sometimes quite difficult to find out what's going on, is that linked items are sometimes dependent on the context. So let's say on quotes you have a different definition than an order, or the linked item has a different value on quotes or an order, and this means that the rules based on linked items have a different meaning or even a different behavior. Sometimes very confusing for users. They come to you and say, okay, my product works in quotes perfectly, in order it has a completely different behavior, or for it's exactly the same product definition, and I don't understand why. If you have a lot of linked items and rules based on linked items, this can generate a lot of confusion and it can be difficult to find out what's going on. So be careful with linked items. Here on this page I have summarized all the possibilities how to define linked items. One is BC-based, that's the last line item. This is the original approach. And you can also use keyword-based, but we only have a few keywords you can use. And the newest one is content-based. So in this case, you are using a variable from a variable map, and the linked item is filled with the value of this variable. Which variable map is used? Out of the box, we will always use the CFG eligibility variable map context. And you can define additional variables and use them when the check eligibility signal is called by the configurator. The advantage of the context service or from this possibility is that the variables from the variable map have a lot of possibilities how they can be defined. They can be defined context specific through integration objects and components. They can be defined for business components. They can be defined through profile attribute values, and they can be defined by calling a business service. So it gives you a lot of flexibility to set up linked item definitions. Yeah, at the end, a short summary. That's actually something that you can keep in mind. And as a basic statement, you can say, try to keep your products simple. Try to reduce any number of objects, whether they are rules, linked items, scripts, UI properties. Always keep them low if possible. and take care that the depth of the classification system and the depth of the customer product is not too high. It should usually not go over a level of 3. Then you will always have a quite good search space, search tree, and the search space for the iLog engine simply means how many possibilities do I have to create different instances. If you can reduce this, then the number of different instances go down, and it will improve the performance of the system. Thank you for attending this webcast. This will conclude my session.
Thank you, Andreas. We hope everyone found the presentation valuable. Due to the fact that this is just a recording only and not a live presentation, we will not engage in a Q&A session. Within 48 hours, the download streaming link and PDF will be posted on My Oracle Support. The doc number for that is 740-964.1. Please note that Part 1 of this presentation was presented on March the 6th entitled Product Modeling Best Practices. You can also find this from that same doc ID. Thank you again, Andreas Rebel, for today's Oracle Advisor Webcast, and we look forward to you joining us again soon. Thank you.